In the previous video, we introduced average and instantaneous velocities, average and instantaneous speeds. Let us now apply these ideas to a problem. So here's what's going on in this situation. So let's say that you were performing an experiment and you were watching a particle move, and you were able to find the position of the particle at each instant of time. Okay. Once you had the information, you plotted this graph of the position of the object with respect to time for 0 to 6 seconds. And based on this graph, we're going to try to answer these questions. Number one is the average velocity for the entire motion. So while we're doing this, so let's look at this. Okay, so average velocity for the entire motion. What do we know about average velocity? Let's first write down the formula. We know that the average velocity is equal to the displacement over the time interval. Now, when the object goes from 0 to 6 seconds, okay, at 0 seconds, where is the object? It's at 10. And at 6 seconds, the object is at minus 10. So the displacement of the object is the final position minus the initial position. And then we'll divide this simply by the time interval, and we will end up with negative 20 over 6, which is negative 10 over 3 meters per second, or you can write negative 3.33. So this is the answer to part 1. Okay, let's do the same thing. And let's answer part 2. Now, what's average speed? Average speed is equal to the distance traveled over the time interval. Okay. Now, let's look at the total distance traveled by the object. If you see, look at this graph. From 0 to 1 second, the object has traveled from 10 to 20, okay, which means 10 meters for this part. From 1 to 3 seconds, the object has traveled from 20 all the way to negative 20, which means it's traveled 40 meters for this part. From 3 to 4 seconds, the object is at rest. Nothing's happening. But from 4 to 6, we see that the object has again traveled 10 meters. So the total distance that is traveled by the object, which is the length of the path, is equal to 10 plus 40 plus 10. And we can divide it by the time taken. And this ends up becoming equal to 60 over 6, which is equal to 10 meters per second. All right, now we're ready to tackle the next question, which is the instantaneous velocity. Now, if you remember from the previous video, by instantaneous velocity, we mean the velocity at a particular instant of time. But given a graph, to find the instantaneous velocity, what you do is you draw a tangent to the graph at the point and find the slope of the tangent line. Now, since at the 2 second mark, the graph itself, okay, the part of the graph is a straight line. We know that the tangent to a straight line is the straight line itself. So all we need to do in order to find the velocity at the 2 second mark is find the slope of this line here, right? And that slope, we see the rise over the run. The rise happens to be negative 40 and the run happens to be 2, which is equal to negative 20 meters per second. The negative sign here should also tell you that this object is moving to the left. All right? So that's the answer to part 3. Now, part 4 of the question, find the interval, okay, or actually there's supposed to be a parenthesis there. Find the interval or intervals when the object is moving to the right. Now, let's make sure we understand what we mean by this again, okay? If an object is moving to the right, you have to ask yourself which quantity is going to be positive. Okay, the answer to that is that the velocity must be positive. So moving to the right implies positive velocity. So make a note of this. This is going to be important. And so all we need to do is look at this graph and ask for which parts of the motion is the object's velocity positive. Okay, and that also translates to, from a graph, translates to positive slopes. So which parts of the motion shows positive slope. So if you see from 0 to 1 second, the object goes from 10 to 20, positive slope. Okay, so one of the parts is going to be from 0 to 1 second. Okay, then we see that from 1 to 3 seconds, the object is traveling in the negative direction. We found in part 3 that the velocity there is negative 20 meters per second. So that's not good. That's where the object is moving to the left. From 3 to 4 seconds, the object is at rest, nothing's happening. But from 4 to 6, we see that the object is once again moving to the right. So the correct answer for this part would be from 0 to 1 second and then 4 to 6 seconds. All right. Now we can ask several of the questions. Another question that could also be asked is during which interval of time is the object moving the fastest? Okay. So I do not have this question, but let's just add this as another one. So fastest would mean uh, so you have to ask fastest when something's moving. Okay, what does fastest mean? Fastest means that the speed has to be the highest. Okay, so speed is, or rather, greatest speed. Now, speed, if you remember, is equal to the absolute of the velocity, of the instantaneous velocity from the previous video. So we asked the question here, when is the speed the highest? So in the first part of the motion, if we were to calculate the speed, the velocity would have been 10 meters per second. For the second part, we calculated this to be negative 20 meters per second. Here it is 0 meters per second. And then for this part, it's once again equal to, actually no, it's equal to 5 meters per second. So the object is traveling the fastest, okay, wherever this absolute value is the highest. So we see clearly that the object is traveling the fastest between 1 and 3 seconds. Okay, so hopefully this problem kind of allows you to put everything together from the very beginning, where we've used the idea of distance, idea of displacement, speed, both instantaneous as well as average, and the same thing with velocity, both instantaneous as well as average. So hopefully all this makes sense.